an invitation. And I'm talking about sort of a brain-mind connection, in particular with respect to neuropsychoanalysis. And I think the main question which we really need to address these days is how are brain and mind connected? So meaning how are brain and consciousness, brain and self and other mental features connected? And only if you understand that, we can properly understand psychiatric disorders. So, and one of the problems in the current landscape that I think it's really we only reach on the surface. So we do all the brain imaging techniques, we see beautiful pictures, but it's only the surface, like here, as you see, often iceberg. Yeah, you see the iceberg is much deeper. And in order to understand the mind, I think we need to understand these deeper levels. My talk is about these deeper levels. So I will not focus so much on cognitive functions, on affective functions, sensory, motor function, but I focus on a deeper level of the brain, because that's what I think is key for understanding mental features. So, and some of you may know that Sigmund Freud himself tried to link psyche and brain, and he had a writing 1895 Project for Scientific Psychology, and basically after that he gave it up because he couldn't see the connection between brain and mind, or brain and psyche, as he termed it. So, and the claim from my side is he simply hadn't the right neuroscience at his time. So then of course you ask, then what is the right neuroscience, the right view or model of the brain? That's basically what my talk is about. And I just indicate very briefly it's about space and time. So that's my talk. First I will give you basically an idea of our view of the model of the brain-psychic connection. Then I will apply that to particular mental features like self. Then I will follow that also in depression and anxiety. So basically, I try to develop a model of brain-psyche, brain-mind connection, applies it to one particular mental feature, the self, and then show how we can use this in psychiatry for depression and anxiety disorder. And as I already indicated, in my case, everything is about space-time, particular how the brain constructs its own inner time and space. I will give some more evidence to that. So let me just follow with the first part, this one, the theoretical model. So what we currently have in the landscape in both neuroscience and neuropsychoanalysis, there's sort of we talk about the psyche, we talk about the brain, and we try to link them to some cognitive or affective function. But however, that connection is sort of contingent. There's no necessary connection. Nothing in the neuronal activity makes it necessary that you have a mental feature, that you have some experience. Yeah. So the question is, how can we develop that necessary connection, like the bridge between two villages at the opposite end of the river, at the two sides of the river. That's what we're really suffering. So, and ideally you want something that is maybe shared between brain and mind. Let me sketch the current situation. Freud and the whole psychoanalysis, particularly nowadays, describe the psyche in dynamic and topographic terms. So dynamic is clear, change, and topography, you know the two topographies about the consciousness by Freud and others. So that's basically a spatial-temporal dynamic, a spatial-temporal description of the psyche. So meaning it has a certain topography, a certain spatial relations, and it has a mental topography, and it has a mental dynamic. It's continuously changing. But there are certain patterns of change. And that distinguishes psychoanalysis from traditional psychology, which is rather static. It's not dynamic. It assumes specific functions, cognitive functions, affective functions, which always remain the same. And it usually considers the psyche in a modular way. So it's not that each function is one particular module, and as such is independent of the other functions. cognitive, affective, sensory, social, etc. functions and their respective branches of neuroscience, affective, cognitive, social, etc. neuroscience. So that's the view of psychology. And what we are currently doing in neuroscience is trying to map such, but that's a problem, because in a way we have in order really to properly match this one, we cannot just view the brain in a static, modular, and non-spatial temporal way. So basically, current neuropsychoanalysis often tries to links the dynamic topographic features with the static and modular view of the brain, which is the mainstream neuroscience, and you see that here. However, what we really need is we need a dynamic and a topographic view of the brain too, because then maybe we can link the dynamic and topography of the psyche to the dynamic and topography of the brain. So here, if you do this, you always have a mismatch. You have dynamic here, you have static here, you have topographic here, you have modular here. So that's why we, in our group, develop sort of a different view of the brain in terms of its dynamic / temporal and topographic / spatial features. So that's what we call spatial temporal neuroscience. I will show you some example. So what we are looking for, what is really shared by psyche and the brain. And here you might know the Tesla cars. Of course, you know the Tesla car by Elon Musk. And that goes back to Nikola Tesla. He was sort of an inventor at the end of the 19th century, beginning 20th century. Very creative guy, highly recommended to look up in Google. Very interesting biography. And he had this beautiful quote: if you want to find the secrets of the universe, think in terms of energy, frequency, vibration. So these are most basic features. And that's exactly the way we conceive the brain. We do not conceive the brain primarily in terms of cognitive, sensory, attention, negative emotions, but we consider the brain in purely dynamic pattern of change and whole brain topographic features. So that's what leads us sort of, this is a paper we wrote 2020, where we say, look, maybe temporal spatial dynamics is shared by brain and psyche. And that's what leads us to spatial temporal neuroscience. So what do I mean by time and space? You are from the Persian background. For you, it's probably no problem to see that time is continuously changing. It's like a river. There's a continuous flow. However, that flow is not contingent. It's not arbitrary. There's a certain pattern to that flow. And I'm interested in those patterns. And the neural activity of the brain constructs its time exactly in this way. So the traditional view of the brain is like this. The brain has not its own inner time, it's just has some perceptual and cognitive correlates of outer time and space in the world. However, what we say, look, your brain has an inner time and space, it constructs its own time and space, inner time and space, and then it matches and compares it with the outer time and space of the world. By the way, the concept of inner and outer time can be traced back to Immanuel Kant, the philosopher in the 18th century. So what is important now that the brain itself, in its neuronal activity, constructs basically the flow of a river, stream of consciousness. It constructs a certain whole brain topography, a certain spatial constellation arrangement. And that's what you can measure in the neuronal activity. And I will give you examples of that later. So this is really the key that we assume here, look, that this inner time and space of the brain, the temporal spatial dynamic, provides the link between brain and mind. And that's what we call spatial temporal neuroscience. Okay, let me get here, but when you say, what is the brain's inner time and space? Here I give you already an example, which I indicated. Look at the waves. Look at the seaside. When you go to the Persian Gulf, you see big waves and small waves. The big waves are very powerful and slow. The small waves are smaller, much faster, and much faster. And that's exactly what we have in the brain too. We have waves, meaning fluctuations. We have very fast fluctuations, for instance, in gamma rhythm, 30 hertz and faster. And we have very slow waves, infra-slow wave, which, for instance, we can measure with fMRI in the frequency range of 0.01 hertz in slow. And what is important that these slow waves, just like at the seaside in the Persian Gulf, that the slow waves are much more powerful than the faster waves. When you swim in the Persian Gulf, you're not afraid of the faster waves. That's negligible for you. But you're afraid of the big waves because they might just smash you just right away back into the beach. And the same is exactly in the brain, and you will see the relevance of that for mental features later. So what we assume that this topography and dynamic of the brain's neuronal activity also surfaces on the mental side. So you have a certain mental inner time. For instance, your stream of consciousness. Your consciousness is like a river. It changes, it constantly fluctuates, it changes, is stronger, is less stronger. But there's a certain pattern in those fluctuations. In topography, you experience a mental space, a mental inner space, which puts you relative to the space of the outer world. Recent paper of a point of view, which is sort of locates you, situates you neuroecologically in the world. So that's what we speak of common currency. So topography and dynamic are shared by the neuronal level and by the mental level. So we approach mental features, and you will see this like in self or changes in depression or anxiety in predominantly spatial and temporal terms. So we have a lot of studies going on where we now ask the subjects about their inner time and space experiences. So that's sort of the theoretical model, and you see it's quite different because we assume it's primarily spatial temporal. That distinguishes from the predominantly cognitive and sensory models of these days, like in predictive coding, which is a very not so much interested in the contents of your perception or cognition. We're much more interested in the structure of the contents over time and in space, how different contents are related to each other over time and in space. Because that's structure which we assume, the context of the single content, which we assume to be key for mental features. So I show you now one example. We develop various spatial temporal theories of different mental features. Like for consciousness, we develop a temporal spatial theory of consciousness, TTC. You can see this on our website with very specific mechanisms on the neuronal side and on the experiential side. Here I show you the example of another mental features, of a spatial temporal view of another mental features like the self. And then I will show you how such spatial temporal view can be very beneficial for psychiatric diagnosis and differential diagnosis of depression and anxiety disorder. So let me start with the self. What do I mean by self? I don't want to go much into metaphysical discussion here. I mean the self, okay, you have a feeling of a self. You look in the morning into the mirror, you recognize your own face, like here, but you also have a sense, a feeling of self. Oh, this is me. And usually this feeling is more sort of on the unconscious side. You're not aware of it. However, you become very aware of it when you lose yourself. For instance, in psychiatry, you see conditions where persons change their sense of self and they no longer feel themselves. Instead, they feel like a different person. Many Jesuses, I encountered some Buddhas, I encountered Nefertiti, Mao, and other, often it's famous people, particularly in schizophrenia. And interestingly, just on a side note, this is also dependent upon the cultural context. So I never encountered a Buddha back in Germany when I was working, or now in Canada, but I encountered Buddhas and Maos in China. I have a lot of connections in China. And the Jesuses I met in Canada. So probably in your part of the world, you might meet certain prophets or certain figures which are very relevant in your culture. Okay. So that gives you a sense, a feeling, and I'm after this feeling. Yeah, this is where does this experience, the subjective experience, the feeling coming from. So here, and there have been a lot of studies, cognitive studies on self, different aspects of self, bodily self, the own body versus the other body, the mental layer of self, trait adjectives related to self. For instance, for you, a picture of Tehran, if you're all from Tehran, it's highly self-specific, whereas for you, a picture from Ottawa in Canada in minus 30 degrees in winter snowstorm is probably not very self-related or self-specific for you, but it's highly self-related for me because I have to survive the winter in Ottawa. So, and what we did here is, this is a paper which we published in 2020 about a meta-analysis of all kinds of studies of self. So we looked for interoceptive studies where the people have to judge their own heartbeat or their own respiration rate. Then we also looked for studies, here these are these studies, then studies where I had basically described the external boundaries of their own self. This is, for instance, the studies by Olaf Blanke, extroceptive or proprioceptive processing of the own body. And then also sort of more the mental, the cognitive self, where you often compare paradigms with trait adjectives, as I just said, a picture from Tehran, a sentence or picture from Tehran versus a picture from Ottawa, snowstorm. And, excuse me. So, and what we observed is, so, and we, this is, I think it's about 200, 300 studies in total, and we separate them according to the paradigm, as I said before. And then you can see here, for instance, all the interoceptive paradigms when you become aware of your own heartbeat and your own inner body or the digestion, these kind of regions are activated. So what you see is the thalamus, no surprise for subcortical interoceptive input. Then you see the bilateral insula, again, no surprise, right and left insula. And you see also the dorsal anterior cingulate cortex. You see that here, you see this here. You also see, interestingly, parahippocampus. So, for the experts among you, these are typical regions of the science network. Yeah, these are really the core regions of what is called the science network, and that has been related to interoceptive awareness. So, no surprise here. Then we looked for all the studies which sort of involved the outer boundary of your bodies, yeah, your skin, your proprioceptive sense, and exoceptive processing. And you saw again the right-left insula, as here. You saw some additional region, anteromedial prefrontal cortex, and you also interestingly saw the temporal-parietal junction. That is the region where Olaf Blanke connected that with sort of this body illusion, where you have the feeling you get out of your own body experiences. And then we had all the studies on the mental self-processing, like here's the trait adjectives or the photos like Ottawa versus Tehran. And you got additional regions of the default mode regions, very typical here, anterior, posterior, cingulate cortex. So when you put everything together, you see the following pattern. So in the interoceptive, you see the insula and the thalamus, which we didn't put in here. But then in the exoceptive, you see again the insula, and you see some additional regions. So this is the temporal-parietal junction, anterior prefrontal cortex, premotor cortex. And then when you go to the mental level, you again see the same regions from the two anterior and posterior cortical midline regions, perigenial, anterior cingulate cortex, posterior cingulate cortex. So this is typical what you call a nested organization. All of you probably know the Russian dolls. You see the smaller doll is nested or embedded within the next larger Russian doll, and so forth. And the shape, the outer shape is preserved, but the size is different. Here you actually see a Chinese crystal ball. You see the same in a much more refined way. This is what is typically called a nested organization. There's a certain hierarchy. The mental self is the highest, but the mental self sort of includes all the regions from the lowest level, the interoceptive. So that's a typical nested organization, and I think it's a perfect example. And that's very typical for the brain. Yeah. So the regions here from the, let's say, the exoceptive level are again reproduced plus additional regions on the mental level. And note that all these three kind of studies which we included here were completely independent of each other. So that's a typical what is called a spatial nestedness. The larger nests or contains the next smaller one, and so forth. That's probably why on the mental level your interoceptive process is. So now we said, okay, so this is basically an interoceptive self, this is a mental self, this is an exoceptive self. And when you plot that, you can in a way say that's a topography of the self. Yeah, very much. It's a mental topography, but neuronally based. And it's a nested topography. Here, this was done by my co-author, former postdoc of mine, Andrea Scalabrini in Italy. You integrated and embedded or nested within the exoceptive self. And those two guys nested or integrated within the mental self. How much these three mental interoceptive self correspond to the id, the ego, superego, I leave that open for discussion. But what is important is basically like different nested within each other, exactly like the Russian. So now that's so you have the regions of the lower level replicated again on the next higher level and so forth. Typical nested organization in spatial terms. Now you say, how about that's the inner space of yourself. That's your mental space, your topography of the self, your inner mental space of yourself. So you see, I do not conceive the self in terms of content, I conceive the self in terms of structure. It's spatial structure, and that is described by nestedness of different layers into exoceptive mental. So then you say, how about the inner time? So your brain continuously, your neuronal activity continues. This is what you get out, a time series. You can get this out of EEG, but you also get a time series out of fMRI. And then, as I already indicated, there's the fluctuations. If you decompose this, you get different frequency bands. You can get very slow, 0.01, and slower, infra-slow frequencies, which you can measure typically at fMRI. And then you have the faster ones, delta 1 Hertz to 4 Hertz, theta 5 to 8, and so forth in EEG or MEG. And what is important, as I understand, there is also a nestedness, because what you see here, as I already indicated, you have power here in the faster frequency. So here you have the power, here you have the frequency, and you see much less power in the faster frequency compared to the slower frequency. Remember my earlier example of the waves at the Persian Gulf, with the big waves being very powerful, smashing you to the beach, and the smaller waves faster, they're not very powerful. And what is typical here again is what is called nestedness. So this is a beautiful figure from one of my students with whom I wrote this paper, David Smith. So look, you have the range, and then but you have always this kind of curve, and the same curve is replicated for a much shorter frequency, and again for a shorter frequency. Again, what you see, nestedness, but now in a temporal way. Yeah, so you see the faster frequency is nested within the next slower frequency that is nested within the next slower frequency, and so forth. And then you have what is called temporal nestedness. And that's very important. Now you say, yes, this is all nice and good, but you didn't say anything about the self so far. Yeah, and what we then tested, okay, we looked whether that such a kind of nestedness in the power spectrum is related to your sense of self. So we measured that in the pure resting state This is fMRI, this is EEG. First, you see the typical power spectrum curves. These are the frequencies. This is the power. Faster frequency has less power. And here you see this for two typical cortical midline regions, medial prefrontal cortex and posterior cingulate cortex. And each of these lines, as I said, this is frequency, this is power, is one subject. So you see already the huge inter-individual subject differences here between each line between the subjects. Some subjects have more power in the faster frequencies, some people have more power in the... And then we linked that, this was in the resting state, to the self-consciousness scale, which is a scale which measures your consciousness, awareness, or sense of self. Different aspects of that, public, private, and social, and what we all correlates with your shape of these curves. So we can measure the shape of this curve, basically the degree of steepness, by what is called the power law exponent, which is basically a measure of the relationship between faster and slower frequencies. And the higher the power law exponent, the more power you have in the slower frequencies relative to the faster ones. And then what we also observe that if your power law exponent is higher, meaning more slower frequencies relative to faster ones, that you have a higher degree of self-consciousness. So you see that there's a direct relationship between the structure of your power spectrum, between slow and fast frequency power, and your sense of self, the strength in your sense of self. And then we, again, here we can see that the nestedness is not only in the brain, but it also translates into your self-consciousness. So basically, yourself is like a surfer on the waves of the sea. Like the surfer, the self prefers the big, powerful waves. And we did the same in fMRI and EEG, and we showed the same findings. Yeah. So between the powerful waves, they show a certain temporal continuity. And that's exactly what your self is about. Your self is about a certain temporal continuity. Despite all external challenges, your self somewhat remains the same. So, and that basically said, okay, that our self is based on space and time, and we... This is a paper from 2016. We say, okay, all the cognitive, affective, and sensory motor functions of the self are based on certain spatial temporal schemata, which are shared by the neuronal and mental level. Here I always like to compare the self with this painting. I'm sure you know this. This is Leonardo da Vinci, The Last Supper, which is hanging in Milano. And when you look at the Da Vinci paintings, it is unbelievable. Remember, it's a 2D canvas and it's static. But when you look at the painting, you have the feeling you're sitting in a 3D room, and you have the feeling it's just a snapshot. You have the feeling, if you were looking a couple of milliseconds later, that the gesture here, this scene of the 12 apostles, one of them betraying Jesus, would be completely different. Yeah. So the question, how does he do this painting-wise? That's exactly what our brain does. It adds a certain dynamic, it adds a 3D spatial topography, and that's what we mentally experience. Yeah. So there's a transformation from the neuronal dynamic and topography into the spatial mental topography and dynamic. So that's the amazing thing, and that's basically what our sense of self is about. So now you say, yes, this is all nice and good, but is that really relevant? Now I show you that these features of the self, the dynamic and topography, are changed in depression. Okay. You all know, because I think many of you have a clinical background, you all know that the self in depression is extremely sad, and what is typical that these depression people are completely focusing on their own self. So when I speak of depression, I don't mean the depression when you get a bad grade in your exam, but I mean the depression which really leads you to the psychiatrist, yeah, where you have no way out and the diagnosis is a major depressive disorder. And what is typically for these people is that they completely focus on their own self. So we described it as an increased self-focus, typical for ruminations, circulating thoughts on your own self. I'm not worth it, but it's all about yourself. And they're very withdrawn from the world, from the social environment, from their relatives. So we describe this as a decreased world focus. So the question, where does this increased self coming from? So I show you the data of a recent paper of ours, which was done by Andrea Scalabrini. As I said, he's in Italy. He's now professor in Bergamo. And he did this very nice paper. And remember the mental self. Oh, maybe I should have not done this. The mental self recruited mainly the cortical midline structures regions, meaning here. So now if you have an increased, expect that you have increased recruitment. And that's exactly what you see in depression. So what he did, he looked for the global brain activity. So this is very important. Unlike many other studies, he didn't just focus on one particular region and then another region and then another. Okay, look, the brain has a global, but that brain activity might be distributed or represented in different regions. It's like, but true, climate change. Climate change has a global effect, has a global source, like the ozone layer, but the effects of that global source in the different parts of the world is very different. Yeah, it's different in the north of Canada with all the ice compared to the desert in Africa. So same here, we look for the global brain activity and the degree to which this is distributed or represented in different regions of the brain. And you can do this with, and what we observed is in the brain, the global brain activity only strongly represented in the cortical midline structures. Network, particularly in the midline structures in depression. You can see this here. This is the image, and you can see this here. It's a huge difference. And then for the fMRI specialist among you, you can also say, okay, I'm not interested in this global activity. I just regress this out. It's called, I take it away. I covary my data for that. It's called global signal regression. And when we did the global signal regression, suddenly there's no difference anymore between depression and health. So that really suggests that it is global activity, which is abnormally strong, represented in the cortical midline structures. And it's not just a local activity from within the midline structures themselves. Then for the experts among you, you also considered a related measure called degree centrality, which is somewhat similar, and you could see as the same findings. So here, I had this global climate change. This is basically like the global brain activity is exactly, oops, sorry. You can see this. So you have ozone layer, but it's represented to different degrees in the world. And that seems to be the case in depression, that the global brain activity is abnormally strongly represented in the cortical midline structures and the DMN. And these are exactly the regions which are recruited during the mental self. Yeah? And then we were interested, okay, however, if the global activity is too much represented in the cortical midline structures, then how about the opposite, the sensory regions, the unimodal primary sensory regions like somatosensory network, auditory network, or visual network. And what we can see that in depression, there's an abnormally strong relationship between the DMN, default mode network, and the sensory regions, the non-DMN. Basically, the DMN, because it's too much global activity, it basically completely enslaves, it pulls the sensory regions to it. And here you see this in the correlation. You see that's an abnormally strong correlation between DMN and non-DMN in the depression, but not in the healthy. Meaning the sensory regions function more or less independent of the DMN in the healthy, but no longer in depression. And that's exactly what you see symptomatically. Everything is infiltrated by your abnormal increased self-focus. Every sensory input is interpreted in that way, and we assume that this is related to this abnormal, strong enslavement, as Andreas Calabrini likes to call it, of the non-DMN by the DMN. So basically the self enslaves the non-self, or it's like a magnet, it's too strong in depression. And that's exactly what we show. And then we say, okay, the DMN has a lot of slow activity. It's very powerful, but it's slow activity. That has been shown in several studies, has long time scales, very slow, powerful waves. And if that is the case, and if the DMN enslaves primary sensory regions, then you would expect that the primary sensory regions also become too slow. So this is exactly what we did here. This is another paper of ours where we looked in occipital cortex, and indeed here you see the power spectrum, the median frequency as an index of the speed of the activity. It's too slow in depression in occipital cortex doing both rest and task. And that's exactly, again, what the patients report. They feel too slow, they cannot follow, they become stressed, and then they socially withdraw. Completely normal reaction once you know that the occipital cortex is too slow and cannot follow the outside world. Yeah, and we also did a transcranial magnetic stimulation cortex. So putting it all together, what we have in depression is very typical, what we described as an increased self-focus, abnormal internal self-related mental content, too much focus on the self, and not enough focus on the external environment. And that's related here to the DMN. We can see this decreased activity in unimodal regions, also decreased activity typically in lateral prefrontal cortex. Now, when you compare that with our nestedness of self, that look here, the blue stuff becomes abnormally strong. This big blue line, it's abnormally strong in exoceptors, become relatively slower, relatively smaller, speaking to the overarching mental self. And again, that's exactly what the patients report. They report this abnormal, strong, not control, which is basically an autopilot, and they do not sense their own body or their internal exoceptive. Yeah? So we assume that that is the consequence of that. So here I show you another example, then you say, where does this abnormal slowness, abnormal time perception coming from? And that may be related to, for instance, life events. So here we did a study, it's a pure psychological study, where we investigated the time perspective in depression people. And we were particularly interested on the impact of trauma. So we measured trauma with a standard scale, this is CTQ, traumatic questionnaire, and this is this scale here, which includes different subscales: emotional abuse, physical abuse, sexual abuse, emotional neglect, physical neglect. And very typical, this is the replication of previous findings. We showed that in depression they have an increased emotional abuse and emotional neglect. This is a replication of previous finding in depression. And then we also did a time perspective scale. This is a Zimbardo time inventory perspective, which measured different dimensions of time perspective: hedonistic present, fatalistic present, negative past, positive past, future. And of course, as expected in the depression, you have more negative past, you have more fatalistic present and less positive past and less future. That's typical. So then we say maybe there's a relationship between childhood trauma, time perspective, and depression. However, you might want to ask, who comes first? Who is first, the hen or the egg? as we say in the Anglo-American world. So here, and you can model that in what is called a mediation model statistically. So we tried out two different models. We tried out childhood trauma, depressive symptoms, and then time perspective as a dependent variable mediated by depressive symptoms. And that's the typical cognitive view where say, oh, time perspective changes are just cognitive consequences of the depressive symptoms. And this did not yield a full mediation model. So for the experts among you, still both are significant, and the direct and indirect effect when you covary for this one, this is not effective. That means that this model, does not really work. When we tried the opposite, we put the time perspective as a mediator, and suddenly we saw that the effect of childhood trauma on depressive symptoms is mediated by the time perspective. So that means that if you have changes in your time perspective due to, let's say, early childhood trauma, you might experience depressive symptoms. However, if you have a childhood trauma and you do not have changes in your time perspective, you will not experience depressive symptoms. So that tells you the importance of the relationship between childhood trauma and time perspective for depressive symptoms. So depressive symptoms are a consequence of the interaction between these two. And obviously, we consider that a strong support for what we call a spatio-temporal view of depression, because your depressive symptoms are based on temporal changes on the psychological level / in your time perspective. And then, of course, we link that ultimately to the brain's time features. Yeah? So that's what we call spatio-temporal psychopathology, that we assume, look, psychopathological symptoms are strongly dependent upon temporal spatial features on the psychological level, which in turn are based on temporal spatial features on the neuronal level. And here you also see the impact of the social environmental dimension. So then the question is, why do they experience time as too slow? This is a paper which I keep very short, which we published 2018. So here, this is a typical view. Depression, the speed of inner time is too slow and too fast in manic patients, and depression is sort of on the medium. In particular, what is important is the synchronization between inner and outer time. The depressed patient is too slow for the faster outer time, so it's retardation. The manic patient is too fast relative to the outer time. And that's what you see here. It's basically the same thing. Here there's a certain balance between inner and outer time and they're healthy. But if your inner time is too slow, like in depression, then of course your outer time is experienced as too fast. And mania the opposite. Your inner time is too fast. Your outer time experience is too slow. For the manic patient, you're simply too slow. Then the question is, how can we link that to the neuronal level? So how can you measure neuronal time speed? We measured it in terms of variability. So neuronal variability, because variability is, if you have a lot of change, you have a lot of variance or variability. So meaning high variability means a lot of change, meaning you have a fast time speed. If you do not have much variability, you do not have, your time speed is rather slow. So time speed is here measured in terms of change and therefore invariant. And what you can see here in depression, that the time speed is too slow. The neuronal variability is too slow. In mania, it's too fast, and in healthy subject, it's sort of in the middle. So that really makes perfect sense. So even on the neuronal level, the time speed matches that is too slow in depression, too fast in mania on the neuronal level. And that's exactly what you see on the mental level too. The inner time is too slow in depression and too fast in mania. Oh, and you get these kind of pictures. I probably, for the sake of time, I keep them short. You can look into the paper. It's 2018. Then let me go. Final topic is, do these changes in self and depression also serve for differential diagnosis? Because that's what you want on the clinical side. You want a marker for differential diagnosis. And that's exactly now I show you in anxiety disorders. So here in depression, remember, subjects were too slow and had too much mental self, too much activity in the DMN, in the default mode network, and that affected their mental self. Made it too small and too slow and too predominant relative to introexcessiveness. Now, in anxiety disorders, we see a different constellation. You see, you all know. So here, rather, what happens if your mental self slow waves become unstable? You become anxious. You all know this painting by Munch. So here we did a study. We looked, for instance, particular for the interoceptive self, because as you know, in anxiety disorders, there's a strong interoceptive component. They get anxious about their heartbeat. In panic disorders, they have the feeling that they have a heart attack, and other bodily symptoms. So anxiety disorders is strongly about your interoceptive symptoms and also your body. So here we applied a heartbeat awareness task where you had to basically become aware of your own heartbeat and count your own heartbeat, which people can quite do well. And you saw that in anxiety patients, generalized anxiety disorder, you saw that they had increased activity in the insula. Yeah? So these are the anxiety people, GAD, generalized anxiety disorder, compared to the healthy subject, particularly in the heartbeat awareness condition and not in the control condition, the pure tone. And you see this for the left anterior and right anterior insula. So these are these pictures. And then we also saw that the abnormal signal change in the insula correlated with an increased body perception awareness. This is a body perception questionnaire scale, and there's a subscore called the awareness. So you have abnormal bodily awareness, meaning the higher your insular activity, the higher your awareness. So that really, and then we also linked that to the DMN regions, and we could see that the functional connectivity and the medial prefrontal cortex here correlated then also with the anxiety. So here, when you put this, this is another paper from last year where we included then also the heartbeat, that the synchronization between the neuronal activity and the heartbeat activity is no longer properly given. So we have a sort of brain-heart desynchronization here. So that means that your interoceptive self is abnormal. However, this is another meta-analysis which a student of mine in Italy did, that the mental self abnormally decreased. So you should decrease functional connectivity, decrease neuronal synchronization of the mental self in the DMN regions in anxiety disorders. So that's an unstable mental self. And then probably you cannot properly react to external stimuli anymore, and your mental self becomes anxious. So that's basically that you have an abnormally, let me go to this one, so you can see that your interoceptive self is abnormally increased, while your mental self is decreased. So the assumption is that maybe there's a decreased top-down modulation from the mental self to the interoceptive self in anxiety. So again, you see, remember the topic was the nestedness of the different layers of cells. So here, it seems that the interoceptive Russian doll is way too big, whereas the mental Russian doll is too small. Yeah? So you have an abnormal nestedness, a disproportion between the different layers of self, anxiety disorders. Abnormal nestedness. Yeah? Conclusion. So what we try to do here, recently Mark Solms suggested a new project for scientific psychology, which I would locate here, but he still did not overcome the gap of contingency. Why? Because he still focused very much on predictive coding and cognitive functions and specific content. He did not really go into the dynamic and the topography of the psyche or the brain. So that's where we say maybe here your temporal spatial dynamics provides a common currency of brain and mind indicated here. And that then also really bridges or eliminates the gap of contingency, because now you have spatial temporal neuroscience, brain dynamics, temporal spatial dynamics, and that is related to the mental features like consciousness itself, and that goes to then that provides a basis for brain functions, cognitive functions. So, and you can see this is basically what we call a project for spatial temporal neuroscience. So this is basically our answer to the initial quest by Freud in 1895 for the project for scientific psychology. So we say Freud would have needed spatial temporal neuroscience, and then we can say a spatial temporal project for spatial temporal neuroscience can address or bridge the gap between brain and mind, something which Freud tried to do in 1895 in his project. And last slide, not least, you say, is this also relevant maybe for therapeutic interventions? And we say, yes. For instance, when you do psychotherapy, you all know, ultimately, it doesn't really matter what personal cognitive behavior, dialectic behavior, or psychodynamic approach. What really matters, and that has been shown, that the psychotherapy method are not as relevant as we think. There's been studies, many studies on that, showing that. But the key factor is the relationship between the therapist and the therapist. And how is this relationship structured? Of course, you can imagine our answer is clear in spatial temporal terms. That maybe if you have a certain trauma, that certain longer time scales which are relevant for the continuity of your them because of the trauma. And we have another study showing that the trauma affect you. Remember the time perspective in the study I showed, the psychological study, and also the neuronal level, that it increases a higher degree of entropy in your brain. So meaning you have less temporal continuity in your neuronal and psychological activity when you have high trauma. Now maybe if you have a good matching between the client and the therapist, that maybe the therapist can provide his longer timescales or slower to solidify and make more stable the patient's sense of self. Yeah? So that's basically sort of a virtual transfer, a virtual connection between the longer timescales of the therapist with which exactly the timescales the patient or the client might lack because of. And successful therapy that basically then is sort of that a patient takes advantage in the therapy in a virtual way of the therapist's longer time scale. I know that needs to be shown, but we're working on these kind of things. And of course, we speak here of the spatial temporal psychotherapy. We also speak of spatial temporal psychopathology. So I come to an end. This is the last slide. Main message, temporal dynamics, spatial topography connect brain and psyche, and that in turn serves as the basis for the various cognitive important that really provides a shared feature between brain and psyche, common currency, as we said, I showed earlier, and that really makes neuropsychoanalysis possible. And that's why I would say that we then might also want to investigate psychodynamic features like the ego, like consciousness in spatial temporal terms on both neuronal and psychological level. And some of these papers and books go into that direction. Thank you very much.
So thank you so much. It was really fascinating. Like I took so many notes for further studies. If you have some more time, can we go for the questions?
Yeah, we can do some questions. Let me just stop sharing maybe. Yeah. Okay.
And also, if anyone is willing to just speak, you can you can open your microphone and speak. I think it's allowed for everyone. So we have one question here. Ida has written how in depth you have gone through the topic and the topics. It's truly wonderful to me. However, I think my clinical forensic psychology background did not help me in grasping each single topic. And she is just committed to studying more. So, like, do you have questions, anyone? So I have a question. So you indicated that there is this higher level of cognitive processing, that is, you indicate mental self-processing, and you set an example like out-of-body experiences and these sorts of examples. So have you actually studied these rare experiences? And my question is, how do you know, like, how do you methodologically experiment that? How do you know what is actually the subject is experiencing, and how do you correlate that with like certain brain activations? How does that happen?
Yeah, good question. So what we do now is often that we ask the question, the subjects the